Friends, so today I am going to cover a very important interview question, which is binary tree maximum path sum, and it is asked in mostly all of the companies like Facebook, Google, Amazon, etc. And the problem is hard, but if you have seen my previous video, I have shown you an approach on how to solve these kind of problems. So in case you have not seen that, I'll put the link below. But for now, let's go through this problem. So this is the problem. So a path in a binary tree is a sequence of nodes where each pair of adjacent nodes in the sequence has an edge connecting to them. So basically we have a binary tree and there is a path from one node to another node. A node can only appear in the sequence at most once. So while calculating these results, we should only take a node only once. And note that the path does not need to pass through the sum of a path is sum of the nodes value in the path. So how we calculate path sum, it's basically nodes value. So for example, this is very simple example. We have a tree with root node as 1, left node as 2, right node as 3. So what is the maximum path sum? It will be 2 plus 1 plus 3. So 6 will be the answer, and it will be from this node to this node. We don't need to calculate the nodes in a path. We just need to calculate the sum of the path. So basically we don't need to maintain whether this answer is from this node 2 1 3. We just have to calculate 2 plus 1 plus 3, and that's it. So this is pretty simple problem. So we see that the path goes through the root and it consists of all the 3 nodes of the tree. So it's simple, right? So let's go back to this problem and let's see. So if I do so there, how many paths are there? So this question can come to you. So even a single node is a path. So this 15 is one path from this node to this node only. 7 is one path, and 1527 is another path. 27 is one path. 2015 is one path. 9 minus 10 20 15 is one path. So I think you got what I am trying to say, that there can be a path from any node to any node, and it does not have to go through the root. So as I told you in my previous video, this problem consists of two things which we need to calculate. One is the local answer, so an answer at a particular node. So for example, I will calculate the answer at this node, 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 and at this node. So we need to calculate answers at each and every node, and then we need to just compare it with the global answer, and if that local values of that node is greater than the global value, we can just update that global value with the local value. This is first task. So first, what is first task? We need to calculate the answer at each and every node. And second part is like we have to pass the current optimal value from any node to its parent, so that its parent can also calculate its value. Because as you know, in these type of tree problems, we start from root, then recursion goes from root to each and every node, first to the left side, then to the right side, and this way we reach to the leaf node. And that's where each node, if it's a leaf node or any other intermediary node, it has to pass the value back to its parent, so that its parent can also calculate its local result, compare with the global result, and update if needed, and also again pass it to its parent. Okay, so let me first draw this and let me tell you how we are going to solve these two things in this problem, and finally we'll get the answer. Okay, so this is the problem, and pardon my drawings, but this is a tree with root node as minus 10, then 9 20, and 20 has two child 15 and 7. And as I told you, in these type of problems where we are asked to compute something or find something, and also we are told that the answer might not go from the root, so there are two things to do. First, calculate the local value, calculate the result at each level and compare it with the global result, and if necessary update that global result with the current local result, and at the same time pass any intermediary result from intermediary node to its parent, so that its parent can also calculate its local value and again compare with the global result, and if needed it can pass back the value to its parent. Okay, so what is the local result? So before going to local result, we need to know what we are going to find the resultant value. So in this problem, the resultant value is the sum of the node values in any path, right? So for example, there is a path from 9 to 7, right? And if we sum each node, 9 minus 10 will minus 1, 20 plus minus 1 will be 19, and 19 plus 7 will be 26. So this path will have value 26. And again we have one path from minus 10 to 7. So again 20 minus 10 is 10 plus, so this will be 17. Again from 20 to 7 we have 27. Same way, you get the point. You have to calculate answer at each and every level, and there the answer can only be a single node. For example, let me draw a simple case where I have only this node as a tree. So we have only root node, there is no left right child. So in this case answer will simply be minus 10. Take a second example where I have root node as minus 10 and left node is 3 and right node is 12. So in this case the answer would be 12, because in all other scenario, for example 3 to 12, the sum will be 3 minus 10 minus 7 plus 12, that is 5, and minus 10 to 12 it will be 2, and 12 is there and again 3 is there, so maximum will be 12 and we need to return this node's value. So you got the idea. Okay, so how do we calculate the local result? To understand this, for example, suppose we are calculating value at this node 20. So at 20, how many paths do you have? First you need to find those things, and then you need to find the maximum of those values and then compare with the result. So for example, there is a path from 15 to 20 to 7. So I mean 15 plus 20 plus 7. Again we can take a path from 20 plus 7, so we can ignore left and also we can ignore right, then 20 plus 15, and at the same time we can ignore both of the child and simply 20. So at each node I have to calculate maximum of these 4 values. So here in this case it's 42, it's 27, it's 35, and this one is 20. So we know the max is 42, so we'll update our global result as 42. Okay, so this is one part, and now what we need to return to is its parent. So this one you need to understand. For example, when this 20 is returning result to minus 10, it can either return its own value or its left tree's value or its right tree's value. It cannot return value of its left, its own value and its right value, because if I am traversing through this 10, I cannot go at the both side and create the result, because the path can only go from a node to a child. So you get the point. Okay, so what I need to result, it should be maximum of either node value, so which is 20, or node plus left value, which is 20 plus 15, or node plus right, so 20 plus 7, so which is basically 20, 35 and 27. So in this case it is 35, so I will return this 35 to its parent minus 10, and again its parent will do the same calculation. So these are the two simple things which I did it here, and if you have seen my previous video, I have shown in detail what does it mean to calculate a local value at a node and compare it with the final result value. And the process to this type of problem is simple. You create a local result at each node and you compare it with the global result, and if needed you update the global result, and at the same time you have to return some value from current node to its parent node, and that should be the optimal value based on the problem. So in this case, because we are just summing up the node, we can either return to its parent its value, or its left children plus its value, or its right children plus its value. So that part you need. Okay, so I am at the code. So as always we need to write first base condition, and we always check if it's a tree problem, if root equals to null, then in this case you no need to create or generate any values. You can simply return 0. If there is no node, the final value is 0. Okay, so once base condition is done, I will just call a function helper. I just need to pass root value to it, and at the end I need to return something. So I can have a global variable called max sum, and we can initialize it with integer dot min value. Okay, and I'm expecting once this helper function is done, it is returned from helper function, we can simply return the max sum values, and we are updating this max sum values at each function call. As I told you, this helper will be running for each node, and when it is running for each node, we'll calculate a local max sum, and then we'll update the max sum if that local max sum is greater than max sum. So this value will be keep on updated at each function call. So we can ignore any return value from this function. We are just interested in the max sum values. And let's write this function. It's private int helper tree node root. Again, first write base condition, and for tree problem, mostly base condition, if root equals null, you can simply return 0. And then there are two steps. First, calculate local result and compare and update global result. And what is second? Second one is return optimal value from current node to its parent node, so that its parent node can also calculate its local result and compare with that global value. Okay, so let's implement one by one. So as we already discussed, so for creating or for calculating local result, suppose I am at this root. So what I need all the sums of all the paths at this node and just take the maximum. And what are the path if I am seeing at this node? Either 15, 27, so this is one, or 15 and 20, so this is also one path, or 27, so this is also one path, and only this node 20. So there are four possible options which from where I can get this path sum value, and at a local result I just need to calculate all those four values and take the maximum of it and update the max sum or global result if that local max sum is greater than this global max sum value. Okay, so for this I need left sum. So left sum will be created using helper function. It's a recursive call with passing root.left, and right sum we can calculate using helper function root.right. And now I can create int local max sum, and as we already discussed, it will be a max of 4 values. So max of root.val or root.val plus left sum or root.val plus right sum, or simply everything root.val plus left sum plus right sum. So any of these four values, whichever is maximum, will take the local max sum, and at the second step I'll just update the max sum, which is global variable, if current value is max. So math.max max sum and local max sum. Okay, so first part is done. So we are calculating local result, and if it is greater than max current result, we are just updating it. And local result can be obtained by 4 variables or 4 values. So again, either this nodes value, or nodes plus left sum values, or node plus right sum values, or all node left and right values. Okay, so what is second step? Second step is we need to return some optimal value which its parent can utilize to again calculate these 4 values and update in case this global result is local result is maximum than global result. So this node can either pass this path to -10, so 15, 20. So basically its complete left part to this its parent, or its right path, so 720, in this case 720 to its parent, or in case if both values are not contributing greater than its own value. So for example, if these both are negative, -15 and -7, so in that case it will simply pass its own value to its parent, and its parent will do the same calculation. So here we only need 3 things, and we'll pass the maximum of those three. And I think you know why we are not taking fourth value, which we used to calculate local, is 1527, which is to say left node and right. But if I am passing any value to its parent, I cannot pass this complete tree over here, because then this will not create any path. So this can either go from -10 to 20 to 15, or -10 to 20 to 7, or -10 to 20. So that's where we are only calculating three values. So we can simply return math dot max of those three. So I will take root dot val, or then take the max of other two, and root dot val plus left sum, or root dot val plus right sum. Okay, so I think I am done, and at the end I just have to implement this max function. I could have simply written many math dot max to calculate this value, but I just thought to use some function, and it is basically int a, int b, int c, int d, and you can return math dot max of a, or math dot max of b, comma math dot max of c, comma d. So because this math dot function only takes two parameters, so I have to use this one. And you can ask me why I didn't use math dot max here. So the simple answer is you can use it, but it will look very ugly here, and when you are doing whiteboard interview, nobody will ask you to implement max function. If they ask, you can implement, but simply they will get the thing like you are taking the maximum of these four, and it will be like good while looking into the code. Okay, so let's run it. It is accepted, and it is submitted, and it is accepted. Okay, now quickly see its space and time complexity. So for space complexity, we are not using any array or something. These are all simple variables, but we are using recursive calls in this function call, and this recursion can go up to all nodes in case the tree is such that all the nodes are either in the left of each parent. So for example, you have three nodes, but root has only right child and second child only has right child. So this, in these type of situation where tree is not balanced and all the nodes are only right or left child of the parent node, so you can have maximum order of n recursive calls, and it will make it a order of n space complexity function. And when it comes to time complexity, again there are no loops, but we are again using recursive calls, and these recursive calls will be made maximum of order of n. So we are visiting maximum of each node, and then we are calculating values. So time complexity is order of n. So that's it, friends. In case you like this video, please like it and subscribe to my channel. I am thinking to make some other videos for tree, and then I will start dynamic programming. But I think we should know tree problems first, because it gives us a lot of ideas about the recursion, which is like essential to know dynamic programming. So, and thanks for watching. Bye.